Wow, Einstein. They say that science is about asking the right questions, and this is at its best, and this is why I love to understand the thinking process rather than the facts themselves. So this is amazing. Anyways, Einstein is still waiting for an answer, and so I'm like, maybe that's just how it is. Maybe there is no deeper
চিকেন তো নে
explanation for that. And Einstein says, Mahesh, let's find a deeper explanation for that. Okay, what do we know so far? When you're falling, you don't feel your acceleration. In fact, if you were to close your eyes, you wouldn't know if you're falling on Earth or you are in some deep
এরকমই
intergalactic
হয়
space just
এরকমই হয়
floating over.
দুষ্টু
And
করলে
if you had
এরকমই হয়
accelerometer with you,
বুঝেছো?
you wouldn't even detect any acceleration. Okay? Now, instead of coming up with
খাবার
some
খাবে তা না,
convoluted
গায়ে
explanation
মায়ে
like
মাখায়।
your gravitational charge just
দুষ্টু
happens to be the
একটা।
same as inertial mass, and that's why you don't feel it, but it's there. Why don't we come up with the most straightforward answer? If
তোকে
you don't
লাগছে
feel
এখনো?
your acceleration
মুছে দিলাম
and
তো।
you can't detect it, maybe it's not there. Which means maybe when you're falling, you're not accelerating at all.
হ্যালো,
And I'm
কেমন
like,
আছো?
hello, there's gravitational force pulling on me. And Einstein said, okay, maybe there is no force of gravity. And I'm like, wait, there is no force of gravity acting on me. I'm just floating there. Then why do I hit the ground?
সারাদিন খাননি
And
তো, তাই
Einstein
এখন
said,
খাচ্ছি।
maybe you don't hit the ground.
সকাল দিয়ে না
Maybe
খেয়ে
it's
আসি
the ground
মশাই।
that's accelerating up at 9.0 meters per second square, and it hits you.
শোনটা মাম্মা আমার।
At first, I'm like, come on, that's crazy. And Einstein says, maybe so, but it answers a nagging question. Because
শুয়ে
it's the
চিবাতে পারিস না তুই?
ground that's really accelerating up at 9.0 meters per second square. From the point of view of the ground, such as someone standing on the ground, it gives you the illusion that gravity accelerates everything down at 9.0 meters per second square. Isn't
এই
that a much
মোটামুটি আছি,
simpler explanation, Mahesh?
বেঁচে থাকার
So
মতো আছি।
this is where the whole gravity must be an illusion, perspective comes from. And this reminds me of something called Occam's razor, which says often when you're trying to solve a problem, the simplest explanation is the best. And again, you can see that's what Einstein is doing over here. But wait a second, Einstein. If there is no
ফেলবি না।
it's all an illusion. Why am I feeling my weight right now? Because Mahesh, the ground and the chair that you're sitting on right now, that's accelerating you up at 9.8 meters per second square. And just like in the airplane, when you were accelerated forward, you felt an opposite jolt due to the lag and inertia. Right now, because you're being accelerated up, due to your inertia, you're feeling a downward jolt. And that downward jolt is what makes you feel like you have weight. There is no real force of gravity. What you feel as gravity is just inertia. And this is why the gravitational charge in the Newton's formula of gravity just happens to be your inertial mass. Because there was no gravity. What you've been feeling all along is just your inertia. It's no different than the opposite jolt you feel when the airplane is taking off. It's the same thing. It's just that the jolt is downwards, and that makes you feel like you have weight. That is insane. That is crazy. So, just to be clear, Newton says the ground is inertia, not accelerating. And it's the falling things that are accelerating. But Einstein says, no, it's the falling things that are inertial, not accelerating. It's the ground that's accelerating upwards. Maybe acceleration and gravity are also the same thing, just two different points of view. So he's trying to generalize things. But hang on, Einstein, your equivalence principle has a big problem. First of all, Earth is round. So if the ground is accelerating up in all the directions, shouldn't the Earth be
খেলছিস
accelerating?
কেন? এটা চিবাতে দিচ্ছি তো, তুই
But
খেলছিস
there's
কেন?
another issue. Falling things also stretch and squeeze. It's just that for small things we don't notice it, but if there was something huge like an asteroid running towards the
পেট
Earth,
ভরেনি এখনো।
it would stretch significantly. Sometimes it can even tear the asteroid apart. And it's not just the asteroids. Even the Earth and Moon fall towards each other, and they're pretty big. So
থাপড়ে না একদম ইয়ে করে দেবো মেয়ে সারা গায়ে ভাত ফেলছে
It's what gives rise to tides. That's why we call this effect the
কি হচ্ছে এগুলো ভালো লাগে না আমার আর
Consider gravity as a physical force.
এই একদম
Gravity gets stronger closer to the Earth. So if you've got a big object,
ফেলছো কেন
this part feels slightly stronger pull compared to this one. So
কেন এমন করছো বলো সকাল থেকে খাওনি পেটটা তো এরকম হয়ে গেছে পেটের মধ্যে কিছু নেই এরকম করলে কি করে হবে হ্যাঁ খাবো কি করে তোমাকে খাওয়াগুলো
But Einstein, you said there is no such thing as gravitational force.
জলদি জলদি খেয়ে নাও
Absolutely no force is acting on any parts of it. No acceleration at all. So how do you explain the stretching? You can't explain the kind of forces, buddy. Your equivalence principle breaks. What you gonna say about that? And Einstein says, yeah, Mahesh, you're right. This means that the
সকাল থেকে না খেয়ে আছো কিন্তু ভালো লাগছে না কিন্তু আমার
in small regions where
খাওয়াচ্ছি খেয়ে নাও জলদি জলদি
but in large
খেয়ে দিয়ে ঘুমিয়ে দেবা
gravitational field varies, it cannot yeah, it's
অনেক রাত্রি হয়ে গেছে আজ কিন্তু মা
And so
আসবে
I
না
struggled with this problem for nearly 5 years, but then I had a
এই তো গুড গার্ল
I found a way to explain how an asteroid can stretch even without any force in it.
তোমাকে খাইয়ে আমি খাবো তারপরে সব সারবো
How is that
তারপরে
even
পড়তে
possible?
বসতে হবে তো আমার
And it says, Mahesh, first let's bring this problem into my territory. Let's draw a space-time diagram. Now, a quick refresher. If a small rock is at rest in space, it's still moving in time, so its graph is straight and vertical. We call this the rock's
খাওয়ার পরে
velocity.
মেটেগুলো খাবা
So
হ্যাঁ
the rock's moving at a constant velocity.
কিন্তু মেটে ভালো খাও বলো
Still straight, but tilted. So, look,
মেটে ভালো খাও না
always give you
তোমার
straight
জন্য আলাদা করে তুলে
world
রেখেছেন মেটে বুঝছো
lines. When the
তুমি
rock
খাবা বলে
accelerates, that world line curves. More the acceleration, more curve the world lines. So remember, in space-time, straight world lines are inertial, not accelerated. And curved world lines are accelerated. Okay, now according to Newton, we can consider the ground to be inertial. Let's assume it to be at rest. And the falling person is accelerating towards the ground. So their world line curves. But in Einstein's model, the falling person is inertial, say at rest. So their world line is straight. And it's the ground that's accelerating up. So far, so good. But what if a big asteroid is falling? In Newton's model, the front of the asteroid being closer feels stronger gravity. So its world line curves more than the back. That's why it stretches. This is the kind of force. And we know this is a fact, so the same thing must happen in Einstein's model as well. Somehow, these points on the asteroid must also move further apart. But wait, Einstein, according to you, that asteroid is inertial. There are no forces acting on it, which means
আর
I
অল্প
can
একটু আছে
assume that all the parts of the asteroid are at rest. So the world lines of these 2 points should be vertical and parallel. There should be no curves, no acceleration. And yet, somehow the asteroid should stretch, meaning the distance between these vertical parallel lines
অল্প আছে বলেছি
How can the distance between parallel lines, straight lines, increase without curving?
যা।
That's
এই যে এই যে এই
impossible.
যে এই যে এই যে এই যে এই যে
And Einstein says, Mahesh,
Hey,
that's
nee,
not
nee,
the
nee.
attitude we have over here. Don't say
Hey,
it's
nee.
impossible. Don't have breakthroughs. Instead, ask, how can I make this possible?
ও বাবা রে
Okay. How can we make parallel straight lines
টুনিকে দিয়ে দেবো ওটা?
move further
তাড়াতাড়ি খাও এই যে
without curving them?
এই নাও খাও
How is that? How can we make that possible? Einstein said,
খেয়ে নাও খেয়ে নাও পুকু খেয়ে নাও
we drew them on a
মেটেটা
globe.
খেয়ে নাও
Imagine 2 people walking north from the equator along the lines of longitude. They start off parallel and they are walking as straight as possible. No
বিছনা
problem.
নিবি না দে বিছনা বিছনা দে বাদ দে
And yet,
বিছনা বলছি
they
চাদর দিয়ে
slowly
বাদ দে
move closer together. Why? Because the surface itself is curved. On curved
I know.
surfaces, look, straight paths can come closer. Now, if the surface was like a
I know.
saddle, then the straight parallel paths could also drift apart. And I'm like, wait. These are not straight lines, Einstein. These are curves, and the line of longitude is a part of a circle. So this doesn't apply over here, right? And Einstein asked Mahesh, what's your definition of a straight line? And I'm like, well, it's the shortest path between two points. And Einstein says, well, a line of longitude is the shortest path
নিনে
between,
বটা
say, the two poles of the earth.
খাবি
So
না
it fits the definition of straight line. Now, to avoid this confusion with this whole straight terminology, the shortest path between any two points is in general called a geodesic. Okay? So, long story short, on a flat piece of paper, if you draw two parallel geodesics, they will have to stay equidistant. But on a
হাতটা ধো না ভাই খেয়েছো কখন
parallel geodesics can converge or diverge or do whatever they want.
হাতটা ধো ভাই তুই আর নোক টোক দিস না তো গা হাতটা ছিলে গেল আমার হয়েছে